Hello guys, welcome to my YouTube channel. Today I am going to show you how we can construct a binary tree from Inorder and Postorder Traversal. In the last video we have constructed the binary tree using the Inorder and Preorder Traversal. So if you haven't checked that video, then my suggestion is to please go and check that video. Okay, so you can check that video after this video, or if you want you can check it now and then you can come and see this video. Okay, so now without any delay, let's get started. So in this problem we have given two integer arrays, Inorder and Postorder, where Inorder is the Inorder traversal of a binary tree and Postorder is the Postorder traversal of the same tree, and we have to construct and return the binary tree. So this is the example. So in this example the input is one is Inorder and one is Postorder. Okay, so before we start to code for this problem, so make sure that you know what is Inorder and what is Postorder. So in order is nothing but in order, first we access the left element, then we go to mid, and then after that we go to right. And what is Postorder? So in Postorder, first we access left, then we go to right, and then in the end we go to mid. Okay, so in this problem our Inorder is 9, 3, 15, 27 and Postorder is 9, 15, 7, 20 and 3. So from here it is clear that the last element of Postorder is the mid. Okay, so this 3 is going to be the root of our binary tree. Okay, so now first in this function public tree node build tree, we have passed the two arrays, one is Inorder array and Postorder array. So from this function return one more function, that is build tree helper. Okay, so return this function build tree helper, and in this function first you pass the Inorder array, after that pass the Postorder array, and now we are going to start from this element, from the last element of the Postorder. Okay, so this third is post end. So how we can give the post end? So just write Postorder dot length -1. Give this as Postorder, and now same way we need to give our this Inorder. Okay, so for Inorder just write 0 because we are going to start from here, that is in index. Okay, sorry, in start. Okay, so here write 0, and here after that the length of this Inorder, because we are going to access all the elements from starting to till end. So what is our inend? So inend is nothing but Inorder dot length -1. Okay, so return this, and now I am going to define this function build tree helper. Okay, so write public tree node build tree helper, and in that pass same Inorder array. Okay, so Inorder is array. Since we are defining function, we need to write like this int Inorder, and after that pass the Postorder array. Now after that I told you first we are going to pass this element, and what is this? This is the end of Postorder. So we can write here post end. Okay, int post end. Okay, and what is this? 0. 0 is nothing but the start of this Inorder. So here we can write in start, int in start. And what is this inorder dot length -1 that I am passing here? That is nothing but the inorder end. Okay, so I am going to write it as int in end. Okay, now in this function we are going to check if our in start is greater than in end, then in that case we are going to return null. Okay, so here write if in start is greater than in end, in that case we are just going to return null. Okay, so this is the only condition that we need to check. Okay, so if our in start becomes greater than in end index at any point of time, then we are going to just return null. Okay, and after that, now one integer variable that we are going to use, that is int root val. Okay, and in this root value we are going to pass what? First element is going to be our 3. What is 3? 3 is nothing but the post order's end. So here I am going to write it like this, post order, and in that, but the index is nothing but post end. Okay, now this is going to be the root value. Okay, so now I am going to create tree node root, and in that node I am going to pass this value tree node, and here pass this value root value. Okay, and after that, now we get this value. Now we are going to find the index of this 3 in the in order. So this is the same process like what we did in the last video, that is constructing a binary tree from the inorder and preorder traversal. So in the same way we are going to find the index now. So for index, write int root index. We are going to find the root index in order. Okay, so how we are going to find? So first start this from the in start. Okay, in start. Now run one while loop, while in order, and in this pass the value of root index in order. Okay, so while in orders and this index becomes what? Root dot value, or we can write is not equal to root dot value. Okay, root value I can give that because we find the value here. Okay, is not equal to root val. In that case, just return, not return, just increment the value. Okay, if this is not equal to this root value, then just increment the root index in order. Index in order. Okay, I hope the spellings are correct. Okay, so now in this way we are going to find the root index in order, and after that, once we find the root index, okay, then we are going to find the right subtree size. How we are going to calculate the right subtree size? So create one int variable, right subtree size, and what is going to be right subtree size? So let's say we find the index here. Okay, we find the index here. So for 3, what is the right subtree size? So how we are going to get the right subtree size for 3? That is in end minus our this in index that we find. So here in end is 4. Okay, in end is 4, and what is this value? 1. So 4 minus 1 is equal to 3. So 3 gives the this size. Okay, So for 3, what is right subtree size? That is nothing but this inend minus this in index. Okay, so we get the right subtree like size like this. Okay, so here right inend minus root index in order. Okay, now first we are going to access the root dot right elements, that is these elements. So how we are going to access these elements? So right here, when recursion, we are going to use recursion. So root dot right, we are going to call this function build tree helper, and in this function pass our inorder array, post order array. Okay, so now last time we accessed these 3, so now we are going to access this element 20. So how we can access this? So this post end, last time the post end was 3, so now we are going to decrement it by 1 to get this 20. Okay, so here I am going to write post end minus 1. Okay, so since we are going to get the root dot right values, so that means that we need to get these values. Okay, so our in start should be root index in order plus 1, so that is 15. From 15 we are going to start, so our in start is from here 15. Okay, so here write root index in order plus 1, and we are going to get all the elements from 15 till end, so our in end is going to be same in end. Okay, in end. In this way we are going to get the root dot right. And how we are going to get the root dot left? So for root dot left, again call the function build tree helper, and same way pass in order, post order, and now what is the post end? So for post end, okay, so for post end what we are going to do, like here write post end. Okay, after that minus 1 that we are doing in the last operation, that is root dot right. And now from this minus 1, okay, from this minus 1 we need to subtract our right subtree size, because we don't need to take the right subtree this time. For the root dot left values, we don't need these values. Okay, for our right subtree we don't need these values, or we can say that we don't need these values in the end from the right side subtree. That is for 15. If I am going to make the 15, then I don't need these values 27. Okay, so that is why we need to write post end as post end minus 1 minus right subtree size. Okay, and then after that we are going to start for left value. We need to start from the starting point itself. So here just write in start, and here like for 3, so we need to get the elements till here only, so one element before the our index, so nothing but root index in order minus 1, index in order is here and minus 1. Okay, so now after that in the end we are just going to return the root. Okay, so let me try to run this code. Okay, so there are some errors. So here E should be not be capital. Okay, and here, okay, there are some mistakes. Let me correct that. Here this is in end only. In order post order length, in order dot length. Okay, post and in start, in end. Okay, okay. I hope there is nothing else. Let me try to run it again. Okay, so here also I defined ES capital in root dot right. Okay, and in root dot left, here also I defined this ES capital. It should not be capital because here I am defining it like this. Okay, so here let me correct it. post and here in and. Okay, I think that's all. Let me try to run it again. So yes, so our solution is accepted here, so let's submit it. Okay, so our solution is accepted. So I hope that you guys are able to understand this code. Please like, share and subscribe my YouTube channel. Till then, keep practicing and keep coding. Thank you.